Hello, I'm Andreas Baranovskis, technical expert at SQLite Consulting and Oracle ACE Director. I would like to present a session from the Oracle Open World 2014 Data Caching Strategies for Oracle Mobile Application Framework. So let's start. A few words about the SQLite Consulting. We are experts in EDF Mobile, and integration with BPM, SOA, and Web Center. We are a small team of experts, and we are focused on the quality technical results. Our customers are global corporations, medium companies, and small businesses. And probably we share one of the largest repository of ADF sample applications on the internet, 8 years and around 700 posts. Let's see the agenda of the session. Firstly, I would like to talk about data caching strategy. Then I would explain data caching complexity and different points around this area. I'll present out-of-the-box Oracle mobile caching options that are coming with the product. I'll explain in detail how to use SQLite database in Oracle Mobile and how to integrate with the web service from Oracle Mobile. Then I'll present two solutions for read-only data caching and as well for transactional data caching. So data caching strategy, what about? Here you can see in this diagram the key principle about data caching strategy. So if we have a server-side application here on the right side and mobile device on the left, so typically you would initially load data from the server-side web service, and then later when you would like to check for the data, for example, or user would like to submit change to the server side and so on, then you should have some logic which would decide if we should check in a local database or maybe we should synchronize data with the web service. So as for example, when user is changing data, we could store these changes locally, and then when user would like to refresh and synchronize this data with the server side, then we should take the data from the local storage and push it to the server side. So basically the flow is like this, that initially we are loading data from the web service, then for the next actions when user is reading data or maybe updating data, we could leverage local SQLite storage. And in those cases when we would like to synchronize data with the web service, we should retrieve data from the local SQLite storage and synchronize it with the web service running on the server side. What is complex and what is the complexity of data caching implementation? I should state first that for the read-only data it's relatively easy to implement it, because you fetch data, then you store the copy of the data on local SQLite database, and later when you would like to synchronize, simply drop the data from the local storage and read it again from the web service. So there is no transaction, and this kind of synchronization is quite easy. Then for CRUD operations, it's more complex because you need to care about transactions. So if the data is being changed, for example, by the user locally on the device, and then another user is changing the same data on another device, and both of them are synchronizing with the central web service, then it's a question of whose data will be updated first on the server side. And in our case, since we are using ADF business components, ADF business components will take care for that and would throw the error for the second user who would be updating the same data later, that for example data was changed by another user already, so on. And you may think about different strategies and how you would like to approach the problem. For example, maybe it's fine if data was updated already by another user, and then your user is updating the data again and overriding the changes of previous user and so on. So it's more tricky, and there are different scenarios to take care. And when we have create, read, update, delete, obviously, and if we are working in offline mode, so we need to keep track of all the changes that user is doing, like updating records, creating records, and so on. So then these changes will need to be synchronized later when user would like to push them to the server. Then there are two main approaches to take with data caching. So it's either out-of-the-box approach or custom approach. With out-of-the-box approach, it's quicker to implement initial solution. It's quick to implement uh, kind of generic caching, but then if you would have some different requirements, it's harder to customize because you get whatever you get, and it's harder to build some custom functionality on top. So if you get a framework like some extension for data caching, it's already a black box, and if you would like to change the way the caching works, probably it's possible, but it's harder to do it because you need to understand how the extension works. You need to have a source code of that extension, and you would need to change it, and then once there'll be a new version of the extension, for example, it will be harder to maintain and migrate from your version. But as I mentioned, the advantage of out-of-the-box approach that probably it will be quicker to start using the caching because you don't need to implement it by yourself. Then custom approach, it makes sense to use it when your data caching requirements are not too complex and you don't want to overload your application with some generic framework. You can implement some basic caching by yourself using local SQLite database directly. So when implementing custom approach, you need to make sure that your algorithm is stable enough and that there are no issues and so on. It works stable. In this respect, out-of-the-box approach maybe is better because it's already tested by others and there's less option that something will break. But on the other hand, custom approach is good for more simple solutions and you would have more control over the code. Now, in terms of default options provided by Oracle, mobile framework for data caching strategies. Right now, there are no caching support in the current production version, but I know that there is coming support for data caching and synchronization when on server side you would run web services on top of business components exposed over REST, and this would allow to sync the data and cache it on the device. There is also a sync config file in the developer available when you create Oracle mobile application, and for this file it should be possible to configure lazy persistence, refresh policy, DB storage folder path, and so on. So this would allow to cache your data on the device and synchronize it with the server. Also, there was extension available previously from the A team for data caching. It's not available anymore, and probably it will be included in the future in the official Oracle mobile framework distribution. So now a few words about SQLite database in Oracle Mobile. It's actually very lightweight and portable. It's represented by a single file. If you would like to, you could even export this file from the mobile device to desktop and check the contents of the database. It supports multiple read-only connections, but if you're executing some write operation, then it's a single read-write connection per time, so it doesn't support write concurrency, but it supports read concurrency. So you could read data from multiple threads, but at one single point of time you can only write with one thread. It supports foreign key constraints and dynamically typed, so you should check and be careful what data you are saving to a database, because it would not complain if you would write number into the string column, for example. There is no role-based or user-based authentication. but it provides encryption support by mobile application framework, so you could encrypt your data and it will be safe to store it on the device. So there is no problem with that. Now there is a screenshot that shows how you could invoke a web service from Oracle Mobile Framework. And in our case, if we want to use data caching, we should not call web service directly from the web service data control, but we should call it from the Java method. And there is Oracle Mobile Framework standard class called EDFM Java utilities, and there is a method invoke data control method. This method allows to define data control, and the method from this data control pass parameters, parameter types, and parameter values to the method, and then the same method will be invoked from the Java. Also, we could get a response and then parse this response to the specific type. It supports basic types, so if you have a nested complex types, this probably would not work, and you would need to use the server's bus and convert your complex types to the basic types and access the web service with the basic types from the mobile. Here's another example of calling data control method. We are constructing a list of parameters, then setting the values and setting parameter types, and invoking the web service to update specific task. So we are passing ID of the task, status description, and calling the method. Here's the algorithm of implementation for read-only data caching. So we have a method that constructs a list of tasks, and firstly, before constructing a list of tasks, we are checking if there are any tasks already in a database. If there are no tasks in the database, so it's either first time when we invoke application, or maybe during previous synchronization there was no tasks fetched. So if there are no tasks, we are loading tasks from the web service. We are calling web service to construct a list of tasks. Then if there are some tasks coming from the web service, we are synchronizing this task to the database. So we are writing the tasks to the local SQLite database, and then we are returning list of tasks. So this means the next time when user would access the list of tasks, it would find the tasks in the database, and it would not invoke the web service. It would come to the else statement and would load the tasks from the local SQLite database. When the user would like to synchronize with the server, refresh method would be invoked. It would firstly invoke sync task to server. So this would synchronize local task to the server, then would load web service and invoke the web service to call and fetch all the tasks from the web service, would construct a list of tasks and would sync this task to the local database. And after the refresh, get tasks method would be invoked automatically, and from this method it would find the tasks already in local SQLite database and would load them from there. And for transactional data caching on mobile application, you would have initially the list of tasks, then you would have a navigation to the another screen where we could edit the task, and once task editing is completed, we would navigate back to the list, and we would navigate through the method update task local. So basically, when we would be editing a task, the changes would not be saved to the web service immediately. We would store them firstly to the local SQLite database, and later during refresh we would synchronize the changes to the web service. So here in this example, the refresh method, this method call for sync task to server is actually responsible to synchronize previously changed data to the web service. Here's the example of method update task local.